This is a standard dewatering centrifuge. Centrifuge has been manufacturing dewatering centrifuges in the United States for decades. As we can see here, liquid comes into the centrifuge in the feed chamber. The liquids and the solids are accelerated, the solids being collected on the inside of the drum, then continue to be discharged to the solid discharge. The centrate flows out over the weirs and is discharged on the liquid end of the centrifuge. Most manufacturers use this basic design and modify the dewatering centrifuge as a thickener centrifuge. A hydraulic baffle disc is installed, and the centrifuge pushes the solids underneath the disc. The seal between the disc and the wall is created so that the thickened sludge or any organic matter will seal between here. Everything in the conical side is solids that are continuously pushed underneath the disc. As you'll see shortly, the solids discharged from the dewatering centrifuge turn more into a paste. That's what others use as a modified dewatering centrifuge. Notice this whole area where the conical section is. This area is waste because it's full of solids. Water cannot release back into the centrifuge, so it's doing nothing for clarification. That's why we decided to utilize the whole length of the centrifuge and created the THK. The THK is not a modified dewatering centrifuge. It is a centrifuge designed for thickening any kind of waste, activated, primary, or even protein and yeast, just to thicken it to about 6%, 8%, or 10% solids. Similar to the dewatering centrifuge, solids are accelerated, collected on the inside of the drum, and then continuously pushed through the centrifuge to be discharged on the solids end, while the liquid travels back inside the centrifuge and is discharged continuously on the liquid end. Here we show again the whole area where the conical section of the modified dewatering centrifuge is wasted. In the THK, that whole area is a clarification room. So we have a much larger clarification area over the whole centrifuge. The whole centrifuge is cylindrical, so the clarification volume, or the G volume, is the largest possible. In addition, we discharge the liquid as well as the solids on a very small diameter, which increases the G volume as well. We also installed a baffle, so the solids seal the area between the bowl and the scroll. The solids are then pushed underneath and travel to the left side of the baffle, traveling through the system of combined piping equal to the level of the water in the centrifuge itself. To discharge the solids continuously, we add air into the solids here. The air decreases the specific gravity of the solids. The specific gravity of water equals 1. The specific gravity of the solids with air equals 0.9 to 0.95. So the hydraulic level of the water is capable of pushing the solids continuously out of the solid discharge on the THK. With the addition of air, we can specify what kind of cake solids we want. If we want thinner cake, say 3%, then we put more air, which makes the solids lighter. Therefore, the hydraulic level of the water pushes the solids continuously out of the centrifuge. This is the air injection. You see little bubbles come up right here, and it is continuously increased or decreased to maintain constant cake solids out of the THK. When other manufacturers use a modified thickening centrifuge design, polymer is almost always needed. In the majority of scenarios for centrifuges, the THK does not need to use any polymer. But if the sludge volume index is too high or we want to increase the flow rate, we can add some polymer. We have the whole clarification area except the area where the injector polymer is utilized. By adding polymer into the pool, we only have to polymerize small particles that settle down. That increases the clarification volume in the centrifuge. By adding the polymer in small amounts, anywhere between a maximum of 1 to 2 pounds per dry ton, we can basically double the flow rate to the THK centrifuge.